Hi one and all, and welcome to today's video on the quadrilateral angle sum. Always good to see you. Did you see my previous video that explained what a quadrilateral was? No? Well, get back there and watch it because that will explain a little bit of the work we're going to do now. And if you have, hey, welcome. If you already knew what a quadrilateral was, and don't tell everyone, but lots of people already do, then this is the video for you. Now, do you see that little red arrow that's appeared over there? What do you mean, no, you can't see it? It's there, look, over there. Yep, that's the one that says you're going to subscribe and help me out on my YouTube channel. Look, subscribers make all the world of difference, and it really helps me think that people are actually watching these videos. I'm here to try and help you. So do me a favour, not only subscribe, get a message out on Facebook, get your friends in there in the classroom. Say, do you know what, guys, I found some guy, he's British, he's a little bit weird, lives in Australia. And actually, he makes real sense. I actually understand what he does. And let's get this subscriber number going up. Greatly appreciated. If not, nah, don't worry about it. You can see what I'm like and come back. Now, quadrilateral angle sum. Easy for me to say not. I need to change my teeth. Basically builds on the work we've been doing previously. Now, this is part of a geometric reasoning module. Ooh, how exciting. Geometry. It's fabulous. And it's real world maths. It's just great. Now, as I normally do, I'm going to tell you that we're going to deal with this lesson, how many angles there are in a quadrilateral, or how many degrees there are in a quadrilateral. We're going to use this basic rule to help us find missing angles in quadrilaterals. Right now, this is great. It's just brilliant because we don't have to use that torture device used a protractor anymore. And to know the difference between an interior and an exterior angle. And to give you a heads up there, if you're interested in interior design, then what does that mean? It probably means inside. And if you're going to change the exterior or something, you know, put on a happy smiley face. No, that's horrible. That's your exterior, which is outside. Now, if you haven't watched the previous video, don't worry about it. I'm just going to do a quick recap here. And when we had that lesson with the triangle angle sum, as I say here, we found that we can use a simple fact to find missing angles inside of triangles. And that fact was there are 180 degrees inside every single triangle. It does not matter if it is a right angle triangle, where there's a right angle there, or an isosceles triangle, or an equilateral triangle, or a scalene triangle, where all the sides are different. Oh, let's make that 2 and 3 there. Every single angle inside that triangle, of which there are always 3 of them, will add to make 180 degrees. Now, having done that, you know, here was an example. So there was a triangle, and I said that was 60 degrees, and that was 40 degrees, and we put a value of x there. And we said, well, how do we find x? Well, moving a little piece of paper over, then I said, well, we know that x plus 60 plus 40 was 180. 60 plus 40 was 100 degrees. And then taking away the 100 from both sides gave me 180 degrees minus 100 degrees. And so x was equal to 80 degrees. Now, again, this diagram needs to be drawn and this working out shown for pretty much every question. You're going to say, really? That seems like a lot of work. Yes, it is. But for these type of questions, generally speaking, you get 3 marks. And if you miss the working out, you're not going to get the marks. And so, although at the end of the exam you got all the answers right, you've only got 1/3 of the marks. Wouldn't that be soul destroying to do an exam where you only got 33 out of 100 because you missed all the working out? If it was me, it would seem a bit dumb, really, but that's a whole new discussion. A teacher saying dumb? Ha! Call the police! Now, having used that idea, we then went on to make things a bit more complicated. And what I meant was, well, there was my triangle, and we just made the line longer. And the reason we made the line longer is because we know that angles on a straight line add up to 180 degrees. So we started merging these things together. We combined them. And so if, for example, I knew that angle there was 120 degrees and that angle there was 70 degrees, I could find that value of x. How? Well, you can only find missing angles inside a triangle when I know 2 of them. At the moment, I know 1 of them. There is my 70. I want to find x. There's my second one. Well, it means now I need to find this angle here with my dot. And you're going to say, well, how do I find that? And that's where we use this rule. We've got a straight line. We've got this little bit here, which is 120 degrees. And there's my dot. And so I know that 180 degrees minus 120 degrees is 60 degrees. And so that missing angle, that dot, is 60 degrees. So there's my 60 degrees. And now I go away and do a second calculation, and I say, well, okay, now angles in a triangle add up to, so there's x plus 70 plus 60 is 180. 70 plus 60 is 130 degrees. Take away 130 from both sides. Gives me that x is 50 degrees. Now, using this type of stuff, actually, believe it or not, builds all of the work we need for this particular video. So we can actually find how many internal angles there are in every single polygon using nothing more than a triangle. Mind blown. How do we do this? Well, if we know that there's 180 degrees inside a triangle, we can actually split pretty much every shape in the world into triangles. Maybe that was a bit bold. Maybe turning around and saying every shape in the world probably wasn't the best thing to have said, because the first thing that goes through my head is a circle. And you're going to go, all right then, think you're smart? Do the circle. And I'm going to say, bring it on. And you're going to go, huh? And I'm going to go, no, we're not. All right, I'm not actually going to do that at all. But the point of it is, I'm now going to split, using a dotted line, just for reference, that quadrilateral, that four-sided shape, into two triangles. And I know that that triangle has 180 degrees and that triangle has 180 degrees. And so in total, angles inside of there must be 360 degrees. Why? Well, I've got 180 degrees plus 180 degrees. Whoa, 180 plus 180 is 360 degrees. And as I say, this can actually work for any single polygon. And I know that's a bit outside what this lesson's about, but 1, 2, 3, 4, 5 shape, five-sided shape. What's a five-sided shape called? A pentagon. Now, this isn't a regular pentagon. And if for those of you who are like, what's he talking about now? It's important. Just a pentagon is a five-sided shape. A regular pentagon is a five-sided shape where all the sides are, in fact, the same length. Now, again, it is really impossible to draw this on these type of electronic tablets. It's pretty good. But the way we can show that they're all the same size is by doing those little marks around them. So, but back to how to find how many angles are inside. Well, first things first, I'm going to take a corner and I'm going to connect that as a triangle, and I'm going to connect that as a triangle. And lo and behold, I have now split that shape into three triangles. How many degrees are in each triangle? 1, 180, 1, 180, 1, 180. So if I do 180 plus 180 plus 180, let's see, the zeros add together, 8, 16, 24, 2, 3, 4, 5. In a pentagon, be it a regular pentagon or an ordinary pentagon, there are 540 degrees. And I have to say, this stuff is very, very awesome. But let's go back. All we need to know now, at this moment in time, is that the angles inside a quadrilateral always add up to 360 degrees. It does not matter if it's convex or concave, or sorry, convex and non-convex, the angles will always add up to 360 degrees. Right, so here's an example, basic quadrilateral. I'm just drawing any old quadrilateral there. Now you're going to say, oh, that's a trapezium, I've seen your previous lesson. And I'm going to go, not necessarily. Now, maths do not draw diagrams to scale. So although I'm going to write here 70 degrees, you're going to say, no, hold on a moment, that looks bigger than 70 degrees. That looks like 110 degrees. All right, let's make it a bit more sensible. There's 110 degrees. Let's make that one 70 degrees, and let's make that one, 80 degrees. And I'm going to say, find X. Now, to find the missing angle, you always need to know 3 of them inside a quadrilateral. And by luck, I know 3 of them here. So I will now do, much like I did before, 110 degrees plus 70 degrees plus 80 degrees plus X is equal to, in this situation, 360 degrees. So 110 plus 70 is 180. 180 plus 80 is 260 plus X is 360 degrees. I want X on its own, so I'm going to get rid of my 260 by taking away 260 from each side, which gives me a grand total of 100 degrees. Let's just check that. 180, 90, 260 degrees. There we go. So, easy, really, with the basic quadrilateral. What about a quadrilateral with an extended line? Again, no difference. Here is a quadrilateral with an extended line. The minute I see an extended line, I'm going to say, oh, I know this. Angles in a straight line. Angles in a straight line. I can do this. So, let me see. Let's say that this one here is 70 degrees. Let's say this angle here is 130 degrees. Let's say this angle here is, 110 degrees. And let's say let's call this angle Y, just to mix things up. Now, to find this angle here, to find this angle Y, I've got to know 3 angles inside. Well, I've got one angle here, I've got one angle here, but hold on a moment, I don't know this angle here. And notice I put a dot by it. Why do I put a dot? To say I need to find this angle. Oh, but I know that that dot and that 130 happen to sit on a straight line. Yes. And if I know that this section here is 130 degrees, and there's my dot, both of those together must add to 180 degrees. So the dot is equal to 180 degrees minus 130 degrees, which gives me 50 degrees. So I'm going to write 50 degrees there because it's going to help me. Is that the end of my question? Nope. That's just part way to help me finding y. So let's see what we get here. Y plus 110 degrees plus 70 degrees plus 50 degrees must equal 360 degrees. Right. Y plus 110 plus 70, 180, 180, 190, 200, 230 degrees. So take away 230 from both sides. Gives me that the angle of y is 130 degrees, and I am pretty stoked by that. See how this works? Pretty much the same. Now we've just got quadrilaterals and straight lines. What about a non-convex quadrilateral? Can we work this out? Well, of course we can. We know that angles inside a quadrilateral is 360 degrees. Doesn't matter whether it's convex or non-convex. So let's go to the oh no, that was horrible. Let's try that one again. Let's try and draw that better. There we go. Let's call this my Star Trek thing. Ooh, how exciting. Let's have this angle here as 70 degrees. We'll have this angle here as 45 degrees. And this angle here as 30 degrees. And we're going to try and find this angle here. Is it inside my shape? Yes. So let's call it X. Is it easy to find? Yes. Have we been given 3 other sides or 3 other angles? Yes. It's trivial. So I know that 70 degrees plus 45 degrees plus 30 degrees plus this value of x must be 360 degrees. Well, 70 and 45 is 115 degrees plus 30 degrees. And notice I'm just doing an extra line of working to make sure. So 145 degrees plus x is 360 degrees. So x is going to be 360. We want to get rid of that, so take away 145 degrees from both sides. So x becomes equal to 215 degrees, which seems reasonably sensible. Look at the size of that angle. It's massive. It's definitely bigger than 180 degrees. But the rules are exactly the same. Now, I've got 2 more examples to do, and these are coming from the Cambridge Essentials textbook series, which I used to teach. And Cambridge have been very, very kind to allow me to use in these videos. So, let's look at this question here. We've got a trapezium, we've got parallel lines, we've got things squidging off it all over the place. It's like, whoa, slow down. But that's all right. We can do this. We can find this. Right. So I'm going to draw the diagram again, just in a slightly different way. So there is my parallel line, and there's that little squarey thing in the corner. What does it mean? It's a right angle. So I'm actually going to write that as 90 degrees. Now, as it happens, I will now also know that this angle here has to be 90 degrees. And you're going to say, well, how did you know that? Well, because these lines, those lines with the arrows, are parallel, which means if this is 90 degrees here, this has to be 90 degrees here. So I've now got 2 angles inside. I know that this angle here is 72 degrees, and it wants me to find this angle here. Well, I happen to know that that angle there and that dot are on a straight line. Oh, I should cocoa. So if I can find the value of my dot, then I can find my value of A. But, here is a quadrilateral. Here is my quadrilateral. Let's highlight it for you here. I need to know 3 of the angles to find another one. So I've got to be able to find this star angle. How am I going to do that? Hold on a moment. Look, I've got another straight line. So I've got a straight line with an angle coming off here at 72 degrees, which means I can find my star. Ooh, I like this. So my star angle is now going to be 180 degrees minus 72 degrees, which gives me the most wonderful of 108 degrees. So there's my star angle. So I'm going to write that now. So 108 degrees is there. Can I now find my dot angle? Well, I should go because my dot is my dot plus 90 plus 90 plus 108 must be 360 degrees. Okay, so dot. 90 and 90 is 180, so that's 288 is equal to 360 degrees. So my dot becomes 360 minus 288. Ooh, what's that in my head? 72 degrees. Ooh, we're getting exciting because now we've got the dot. We know this dot is 72 degrees. Can I find my value of A? Well, I should go because if that's 72 degrees, then there is my straight line. So A is equal to 180 minus 72 degrees, which happens to be hold on a moment, that 108 looks very familiar. Well, again, some of you asked me today what physics was, and I'm like, physics. Well, yeah, there's some special rules, and we've already used the F rule. Funnily enough, in this shape as well, there is a Z rule. So there's a Z, which means I know that this corner angle here and that corner angle there are exactly the same. I could have gone straight to 72 and actually then taken that away from 108. Now, those of you who are watching going, what? Don't worry about it. And dealing with one more question, making quadrilaterals. This is also taken from the Cambridge Essentials textbook series, and I think this is great because first things first, this is a trick. It's trying to trick you because you can most of my brain or most of your brains will be saying, all I can see is two triangles. And I'm like, yes, but remember, two triangles will make up a quadrilateral. Now, what do we notice? There's lots of things here, and I'm going to zoom in on this to make the diagram a little bit more fuzzy, but a little bit larger. We know that these signs here, these little lines here, mean it's an isosceles triangle. And those of you who watched my previous video will say, well, actually, if I put arrowheads on the end, it's pointing to the two angles that are exactly the same size. So while I now know that this angle here is 70 degrees, I know that this angle here is also 70 degrees. How is that important to me? Well, making this slightly bigger and slightly clearer, we know this whole angle here is 70 degrees. And what do you see here? A right angle. So I now know, drawing that corner bigger, I've got something here that is 70 degrees, and I know that all of this added together is 90. So hopefully you will know that if I was to draw a dot here, the dot plus the 70 degrees must be 90 degrees. So take away 70 from both sides, gives me 20 degrees. So I now know that this angle here is 20 degrees. And I suppose we should really say to ourselves, what is it they're trying to ask us to find? And it's this angle here, which is angle A. Can I now do that? Well, yes, because angle A is inside a triangle. So here is a very quick drawing of my triangle. There is angle A. I know this is 30 degrees, and I now know that this must be 20 degrees. Oh, that's okay, because angles inside a triangle add up to 360 degrees. That's what this whole video has been talking about, isn't it? No. Because we're trying to trick you. This angle is actually, yes, it's a triangle, so it's 180 degrees. So I now know that A plus 30 degrees plus 20 degrees is 180 degrees. Add those two together, gives me 50 degrees. Is 180 degrees. Take away the 50 from both sides. Gives me the stunning value of 130 degrees. Ladies and gentlemen, let's take this down. And a round of applause. Can I hear a round of applause? Yep, you're slow clapping, aren't you? Anyway, okay, fine. And really, that's pretty much it for this whole lesson. Now, if you are currently taught by me, there will undoubtedly be work for you to do in the work guide. But if not, and you're out there in YouTube land, and there are 8 subscribers from Hull. Hey guys, how are you doing? Really good, thank you. I'm done. We looked at the quadrilateral angle sum, and we looked at how we could find that angles in a quadrilateral add up to 360 degrees. Triangles are 180 degrees. And you know what? I think I'm pretty much done. Now, as is normal, I do the whole, have you subscribed? No. Well, ladies and gentlemen, there is that subscribe button. It really would help me if you could hit that subscribe button. If not, there's another video loading for you over there. I'm done. Thank you very much for taking the time and watching this, and I'll look forward to seeing you in our next video. MaffsGuru out.